In this video, I'm going to show how the stack works on the J8CM. I'm also going to give you a brief look at the J8CM assembly language, and I'll show you quickly how the compiler works. In the lower right of the screen here, we have the Atom editor, and in that is an assembly language program that I wrote for demonstrating this the stack operations. So we got the asterisks here, uh, designate that as a comment, and then below the comment we've got this origin statement, which says that the next location below that statement is going to be memory location 64. And the DAT statement says that we're going to put 255 into location 64, and A is a label for it. And then we have subsequent memory location 65 is labeled B, and that's going to have that bit pattern. And 66 is labeled C, and it'll have that bit pattern, 153. Then we come down to the next origin statement, and it has a 40, and this is where the program is going to be loaded in location 40. We've got a start label to designate that first instruction, and the LOD is load the accumulator, and we're going to load it with A, so we're going to load the accumulator with 255. PSH, we're going to push the accumulator, the contents of the accumulator, onto the stack. Then we're going to load B into the accumulator, push that, C, push that. Then we will clear the accumulator, and then we will pop the last item to go on the stack, so it'll be that value of 153. When we do that pop statement, it's going to pull that off of the stack and put it in the accumulator. We'll clear that, pop the next item, clear that, pop the next item, and then clear it once again. And then we'll have our halt statement, and the start label will load location 40 back into the program counter. I'm going to go up here to the compiler, and I'll select 1 to compile the file, and the file name is stack ops. I don't put the ASM extender on there. It puts that on there automatically, so all I hit is the file name without the extender. And it runs through, and we'll look at this when I'm demonstrating or talking more about the compiler, but I will show you the output that is created. In this directory, we have the stackops.asm, so that was the assembly language source code. And if I do an ls now that I've run the compile, you can see that it created 4 files, a .ldr file, and that is what I call the loader file. That goes in, if I'm going to use the IO input stream, I would use that loader file to load that IO input stream on the IO panel. You might remember that if you saw my first introductory demo. We are going to use the .obj file, and that will load the program directly into memory. .sum and .sym are more for troubleshooting the program, and we're not going to look at that today. Come up to then the J8CM main menu and look at memory just real quick, and you can see all our memory pages are empty. I'll return, and I'm going to go to item number 4, the loader, and I'm going to select item number 1, that's to load the .obj file directly into memory. Again, I put in stack ops and no extender. It's going to automatically look for that .obj file. Loads it pretty quick, it's a short program. If I go back to the main menu and we look at memory now, displaying the contents, you can see that our program is located here, beginning at location 40, all the way to our halt statement down here. And I page forward, and there at location 64, 65, and 66, we have our bit patterns. And those are what we're going to use to put into the accumulator and then push onto the stack. So I'll go to the front panel and go to the program counter and load 40 into the program counter we got to exit, and then I'm going to just step through the program once again. As I explained, we've got to fetch and execute, or we could run, but it's for demos like this, step is the thing to go with. So when I execute the first instruction, it's to load the accumulator, and you can see it loaded all those ones from memory address 64. I go to the next instruction, and now we've pushed the contents of the accumulator out to the stack, and you can see that the stack pointer actually decremented from all zeros to all ones. Let's see what else we care. Let's just go and look at the stack pointer right now, or the, excuse me, the stack itself. So I go to memory and display contents, page to the back, and you see all those ones have been pushed out to that last memory location, 255. Now we'll go back, turn the main menu back to our front panel, and step through the next couple of instructions. So we loaded the accumulator. Now we've got alternating zeros and ones in the accumulator, and we'll step forward, and we push that now out to the stack. You can see the stack pointer has decremented. So we'll exit and we'll go look at the stack. Now you can see our alternating ones and zeros have been pushed out onto memory location 254 out on the stack. I go back to the front panel and we'll execute the next couple of instructions. Load the accumulator. Here's our bit pattern. And we'll push that out to the stack. Now the stack pointer is decremented once again. And we'll go look at the stack. That's the memory, and go to the end. And now you can see we push that third value then out onto the stack. Now we're going to go back and we're going to pop the stack, and it'll start with the last in is going to be first out. So let's go back, front panel. Our next instruction will clear the accumulator, and then here we've popped the contents. You can see the stack pointer is incremented now, and the accumulator now has that bit pattern from the top of the stack. So if I go back and look at memory, oops, I went too far. Let's look at it again. There we go. So now you can see that location 253, 252, 3, whatever. Yeah, 253 is empty, and because we popped it into the accumulator. So let's go back. Next step is to clear the accumulator, and then we have another pop. There's our alternating zeros and ones, and once again the stack pointer is incremented. We can go back and look at the stack, and you can see we've got just the one memory location left. Now I'll go back and step, and there we go. We've popped that last value off the stack and loaded it into the accumulator, so it's all ones. The stack pointer is back to 0. Let's go look and verify that the stack is now empty. There we go, stack's empty. And back to our front panel, we'll clear the accumulator and then halt. And the program counter is loaded back to 40, so we could start the whole process over again. That's the basic stack operations. The stack is also used for subroutines, and I'll demonstrate that in a future video. I hope you found it interesting. Thanks.